Hello, biology class, and welcome to our lesson on atomic theory. You may follow along and take notes because these are the only notes we will do on atomic theory. So, my first question for you, there's no Padlet to answer today. Just think about it on your own, and maybe you can put a little answer in the chat box. How do you organize things? Personally, my favorite way to organize things is by color, and my entire bookshelf at home is actually organized by color. But I want to hear from you. How do you organize? And again, this lesson is on atomic theory. So by the end of today, you will be able to identify the number of protons, neutrons, and electrons in an atom, which is really the smallest of the small things that make up living beings. So carbon atoms are a great example to start with because atoms are a very, very small building block to greater things. They're not alive, but they do play an important role in life. And so we're going to spend some time over the next few days talking about atoms, elements, molecules, and compounds that help contribute to our life. So carbon is a great example. Arranged in one way, it can be made to be the graphite in your pencils. And arranged another way, it could be made to be coal. And arranged in this way, it is able to serve as a diamond. So carbon, depending on how the carbon atoms are arranged, can be a variety of different things. Here's an example of silicon, which is an element on the periodic table as well. It's used in a lot of computer chips, but it's also very shiny. So when we talk about organizing things, the way that we organize elements is on the periodic table. And throughout this unit, you will have access to a periodic table on every test or quiz you take. So today is going to be a little bit about becoming familiar with this table and how to use it. You can see that the elements are arranged in a certain order, going all the way from 1 up to like 114, and it's in a very specific fashion. So there's 3 questions I'm going to teach you how to answer today. First of all, how do you find out the number of protons in an atom? Second, how do you find out how many neutrons are in an atom? And thirdly, how do you find out how many electrons are in the atom? So first of all, a quick little disclaimer. Periodic tables can kind of be considered like scientist art. There's no specific standard way to make a periodic table, and there's a lot of creative ones out there. But in general, I'm going to break down what a box on the periodic table looks like. One of the first things you're going to see is what's known as the atomic number. And this is how the periodic table is organized. So if you take a look here, you can see we go from 1 to 2 to 3 to 4. And right now we're looking at element number 8, which is oxygen. The atomic number is the same as the number of protons in the atom. Next up, we see the element symbol. This is a 1 to 2 letter symbol that represents the name of the element and can be used in shorthand or in formulas. So oxygen has a pretty straightforward symbol, the letter O. Sometimes, though, you may see a symbol that doesn't quite make sense. For example, this element, Pb, is lead. Now, you may be wondering why that is. Well, some of the symbols are already taken, but also a lot of the symbols are actually derived from the element's Latin or Greek name. So the Latin for lead is plumbum, which kind of makes sense because our plumbing used to be made out of lead pipes. So plumbum, plumber, plumbing, Pb is the symbol for lead. Aurum, A-U-R-U-M, is the word in Latin for gold. So the symbol for gold is AU for aurum, and that's why. So if you see any symbols that don't make sense, you can easily Google Greek sodium, Latin sodium, or whatever element it is, and you can find out why it's called that. Next, we have the element name. That's pretty straightforward. It's going to tell you the actual name of the element. And then finally, typically on the periodic table, we see this at the bottom, we are given a mass number. Now, for the purposes of our class, most of the mass numbers are going to be equal to the total number of protons plus the number of neutrons. But on the periodic table, it's important to note most of the times you will see a mass number written as a decimal. And this is because there are certain atoms of the same element that have different numbers of neutrons and therefore a different mass number. And so the number you see on the periodic table represents an average of all the different masses in existence. So that's why we see 15.999 instead of a hard whole number. And we'll talk about that in a little bit. So now we're going to break down the subatomic particles in the atom. These are the tiny particles that make up the already tiny atom. And the first one we have are protons. Protons are positively charged particles found in the center of the atom, which we call the nucleus. Okay, they're found in the nucleus, right in the center. And in a proton, they provide a positive charge to the atom. So they give the atom a +1 charge. And they also give the atom a +1 to the mass, which is pretty cool. So they contribute to both the charge and the mass. Now, to find the number of protons, this is your freebie question. Everybody should be able to get these questions right because, as I mentioned, you will have access to a periodic table on every test or quiz for this unit. And remember, the number of protons is the same as the atomic number, which is how the periodic table is organized. So for oxygen, our atomic number is the number of protons, which is number 8. So there's atomic number 8, and that means that oxygen has 8 protons. Let's try another. Let's find the number of protons for hydrogen. So I'm going to pull up my periodic table here, and I see H for hydrogen. Hydrogen has 1, atomic number 1, so it's going to have 1 proton. Make sense? Great. Go ahead and try magnesium. Magnesium on the periodic table, Mg. Here's the atomic number. How many protons does it have? Awesome. It does have 12 protons. Next up, let's try neon, Ne. You're right. It does have 10 protons. And finally, let's try lithium, Li. You've got it. Lithium has 3. I'm going to talk a little bit about the neutrons. Now repeat after me. Neutrons, neutral. Neutrons, neutral. Neutrons are neutral. They do not contribute to the charge of an atom. When you add neutrons on, it does not affect the chemical charge. Neutrons do, however, affect the mass. So in order to find the number of neutrons, we always have the number of protons because it's on the periodic table. So all we have to do is take the mass number and subtract the number of protons. Now, a lot of times, if you are not given the mass number, you may have to use the periodic table. In this case, you can round to the nearest whole number and then subtract the number of protons from the mass to find the number of neutrons. So in this example, with oxygen, I'm going to round 15.999 to 16. And then I'm going to subtract the number of protons, which is 8. And I'll show you what that looks like on my whiteboard. As you can see here, 16 minus 8 equals 8, because the number of neutrons equals the mass number minus the number of protons. The mass, 15.99, I rounded to 16. I subtracted 8, and I ended up with 8 neutrons. A lot of times you will see that the mass number, the protons and the neutrons are close in number. Not always exactly the same, but close. So let's take a look at hydrogen, H. Hydrogen has a mass of approximately 1. I'm going to round this to 1. And it has 1 proton. 1 is the mass number, minus the number of protons, which is 1, equals 0. So hydrogen actually has 0 neutrons. Pretty interesting. Let's try magnesium. Magnesium is atomic number 12. And its mass number is around 24. So here we could do the number of neutrons equals 24 minus 12, which I got from here. 24 minus 12 is 12. So magnesium also has about 12 neutrons. Go ahead and try the next two. Try neon. Awesome. Then go ahead and try lithium. Great work. The final subatomic particle we're going to talk about today are electrons. Now, electrons are negatively charged particles. They give the atom a -1 charge, a -1 charge. But they are very, very, very tiny, and they are not found in the nucleus. They actually circle the outside of the atom in what's known as an electron cloud. And they have no mass for as far as we're concerned because they're so tiny. They do weigh a little bit, but compared to the protons and neutrons, basically nothing. A way you can envision it is if the nucleus with the protons and neutrons was a football on the 50-yard line of a football field, right in the middle. An electron would be the same size as a pea, and it would be located all the way out in the parking lot. Yes, a vegetable pea. That's how little an electron is compared to a football-sized nucleus. So to find the number of electrons in an atom, we are going to take the number of protons and subtract the total charge. So in our given problems, they are going to give you a charge on the element. If they do not give you a charge, that means you assume it's neutral. And if it's neutral, that means the charge is 0. So let's try this one. Oxygen with a -2 charge or a -2 charge. Remember, the number of electrons is the protons minus the total charge. So if I look here, right, oxygen has 8 protons. And again, they told us it had a -2 charge. So my number of electrons is equal to my protons, which is 8, minus -2. And that's going to give me 10 electrons. So an oxygen atom with a -2 charge has 10 electrons and only 8 protons. That makes sense because the oxygen has a negative charge. So it means it has more electrons than protons. Let's take a look at another example. We'll try hydrogen. Here's hydrogen. Hydrogen has 1 proton, and they did not give us any electron number. So we're going to assume that hydrogen in this case is neutral, meaning the charge is 0. So the number of protons is 1 minus a 0 charge equals 1 electron. So this hydrogen atom has 1 proton and 1 electron. They balance each other out, and so we're equal. Give chlorine with a -1 charge a go. You're right, it will have 18 electrons. How about lithium with a +1 charge? This lithium would have 2 electrons, which makes sense because it's positive. So that means that you're going to have more protons, it has 3, than electrons, which is only 2. And finally, let's try magnesium with a +2 charge. That's right, it'll have 10 electrons. And I know I said that was the last one, but let's give sulfur a go. Sulfur with a -2 charge. Really great work. So here are some more practice problems that you can try your hand at, and these will be on an exit ticket for you to make sure that you understood the lesson. You will be finding the protons, neutrons, and electrons of these 6 elements. Pay attention to the charge, especially on these problems. Other than that, we'll head back to class on next week, and you can ask any questions that you have. But hopefully you were reading and taking notes. Have a good day, everyone.